We are on chapter 1, page 13, and we are looking at least common multiples, and that is abbreviated as LCM. And essentially what we're trying to do is we're trying to find out when will these two numbers, 6 and 8, essentially when will they land on the same number. We're looking at multiples, so when you think of multiples, you should be kind of thinking in your head, how do you count? So when you see or hear multiple, you're thinking about counting the numbers. Well, there's a couple different ways to do these types of problems, and here's one way. All we do is just list all the numbers. 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30, 6 times 6 is 36, 6 times 7 is 42, and 6 times 8 is 48. Now, we're doing a little bit extra here because all we need to know is the first time the number lands on the same number. Now, just as we counted with 6, we're going to do the same thing with 8. 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, 8 times 5 is 40. Now, if some of you have seen a similar number in the top row and the bottom row, that means we can actually stop counting. 24 right here is found when 6 times 4 is 24 and when 8 times 3 is 24. So for 6 and 8, what we would say, the least common multiple of 6 and 8, your answer would be 24. Right below that problem on page 13 is another way of doing it. It's a Venn diagram problem. And with the Venn diagram problem, they're simply asking us to break down 6 into prime factorization. What times what gives us 6? 2 times 3. What times what gives us 8? And for 8, if you could break it down, it would be 2 times 4, but then I'm going to break down 4 into 2 times 2. Now with the Venn diagram here, what goes in the center? The numbers that they have in common go in the center. So let's change, let's go red. We're going to cross these 2's off because they both have a 2 in common. That goes in the center. Now we'll label this part of the Venn diagram 6, and over here, this part of the Venn diagram 8. Notice the 2 goes in the middle because 6 and 8 both have the 2 in common. The 3 would go over here, and these, there's your 3, and then these 2's would fall in to the 8 part of the circle. Now you might be asking yourself, well, how do I find the least common multiple by doing the Venn diagram? You would simply have to multiply all these numbers out. So you would do 2 times 2 times 2 times 3. And if you work that out, guess what you're going to get? You're going to get 24, which is the same number we got on this side when we did the multiples. So 2 different ways of coming up with the same problem. One is called using the multiples or just counting, the counting method, and then one would be using the Venn diagram, and this would be using our prime factorization method. Now, which one works the best? It all kind of depends on the numbers. If you can easily count the numbers, like 6 and 8 are very easy to count by 6's, count by 8's, that might be your best method. Sometimes you might get larger numbers where it might be a little harder to count, then it might be better doing the Venn diagram method. So 2 methods, chapter 1, page 13, to find the least common multiple of 2 numbers.